Welcome to 16th International Conference of Business Informational Security, BISEC2025, organized by Belgrade Met University. First presenter for the day is application of the meter attack framework in the context of university networks. Presenter is Mirko Miladinovic, Savo Tomovic from University of Montenegro. Do we hear each other?
So, hello everyone, and thank you for being here. My name is Mirko Miladinovic, and I'm here together with my mentor and Professor Savo Tomovic from the University of Montenegro. And we will present you our scientific work, application of the MITRE attack framework in the context of university networks. So, let's begin. University networks are extremely dynamic environments with thousands of devices, diverse operating systems, and users with different technical knowledge. And this creates an environment where visibility is fragmented and security controls differ across departments, making universities a popular target for phishing, credential theft, ransomware, misconfiguration-based attacks, and other types of attacks. So the goal is to evaluate how effectively the framework can be applied to the network of the University of Montenegro. So MITRE attack offers exactly what such environment lack, a structured mapping of adversary behavior, a way to measure visibility and detection, common language for both technical teams and management. We gathered detailed information from CIS technical staff using a structured questionnaire, and this gave us a picture of university network, and we saw that main operating systems are Windows and Linux. Infrastructure contains virtual machines, network is segmented, and key assets include the databases, mail servers, different platforms like e-learning platform and e-index platform, and security controls are FortiGate firewalls, multi-factor authentication, and host-based firewalls. What became immediately clear is that the environment is diverse and complex, and any assessment must be done carefully. So critical system cannot be shut down for testing, which is typical for academic institutions. So we try to find another solutions, and we choose some other tools. For main threat vectors, according to the questionnaire, we could determine main threat vectors and predict which results we can expect at the end of our analysis. And some of them is phishing campaigns, credential theft and privilege escalation, exploitation of misconfigurations and outdated systems, and etc. So first of the tools we used is the tech that was used to evaluate visibility and detection coverage of attack techniques developed by MITRE attack organization. And we applied two modes, visibility modes, which shows what events the infrastructure is technically able to observe. And on the other hand, we used detection mode, which evaluates whether a malicious event can be identified using analytics and rules. The results were visualized in MITRE attack navigator, giving us an intuitive map of strong areas and visibility gaps. So on this picture, we can see visibility mode layer in navigator. And on this slide, we can see detection mode layer. So next step is to emulate attacker behavior, and for that we used MITRE attack Caldera, an automated adversary emulation platform fully based on MITRE attack framework. For monitoring and detection, we used the VASU-CM, which collects logs and correlates them with attack techniques. And this combination allowed us to run realistic attack simulations, to observe how the system responds in real time, to measure detection accuracy, and to validate attack coverage in practice. So one of the first operations we did is agent worm, and this operation simulated a worm attempting to steal credentials from configuration files and common history, while also mapping the network. So we can see here some tactics like collection, credential access, discovery, and their abilities to parse SSH configuration, to dump history, collect ARP details. So, for example, bash history extraction succeeded immediately, showing how easily credentials can be exposed if command line hygiene is weak. And this is a common and extremely simple credential theft technique. On the other side, attempts at network discovery partially failed, and that's a positive sign indicating some network hardening. So even simple techniques can compromise user accounts if shell history is not properly managed. And this is a common issue in research labs and shared servers. Next operation is collection agent, and this agent searched for files with specific extensions, created a staging directory, and prepared the collected data for exfiltration. And if the university does not monitor file system behavior or abnormal directory creation, data can be collected quietly over a long period of time, which is really dangerous for research data, student information, and even financial documents. Next one is defense evasion agent, and we can see that this agent demonstrated sophisticated techniques used by adversaries to hide their presence, like clearing logs, disabling system firewall, modifying tools. So key observations are that Caldera successfully removed common history. We have hidden files that were created without leaving noticeable traces. We have timestamp modification that succeeded, and its technique often used in APT's campaigns to confuse investigators. So defense evasion remains a major blind spot, and this confirms what we saw in the detection map. Many of these techniques had no analytical coverage in WASUCH CM, which is consistent with the CM showing few or almost no alerts during these evasive actions. And this operation provided some of the most valuable insights of the entire study. We can see here some graphs that presents steps that defensive evasion agent did. Next operation is discovery agent, and discovery techniques, although simple, give attackers everything they need to plan escalation and lateral movement. And this highlights the need to detect reconnaissance behavior early, because catching an attacker during discovery in early stages of their attack can be a really great opportunity to stop them in their plan and to stop the intrusion. So as Caldera executed its operation, WASUCH showed a significant increase in alerts, especially during credential access attempts. And most detected tactics involved credential access, brute force, authentication anomalies, and there were frequent alerts such as SSH login failures, checksum changes, and that led us to the logical conclusion that CM is capable of detecting the noisy stages of attack, like brute force, but stealthy or more sophisticated techniques remain invisible. And this is common in environments where endpoint telemetry is limited or not consistently deployed. So, for example, we can see here one dashboard, part of the WASUCH dashboard, and we can see how alerts evolve over time, and we can see different tactics rule by attack or tactics organized by Mitre attack framework. On this slide, we can see also some other graphs that helped us to make an analysis for this network. And based on the complete study, detect analysis, adversary emulation, CM evaluation, we can confidently state that Mitre attack is effective and fully applicable in university networks. And despite the complexity and openness of the academic environment, ATAC provided a clear, structured way to measure real security posture. So we can use it also for this kind of organization, not just for enterprises. On the other side, Caldera simulations reveal strengths and visibility gaps across the different tactics, and the operations reflected exactly the kinds of actions taken by modern APT groups, which can help us to address the visibility gaps in system. Without the necessary data sources, even the best CM cannot detect advanced techniques. And that led us to conclusion that continuous improvement is really essential. Simulations should not be one-time exercises. They should drive regular updates to logging, detection rules, and defense configurations. And also the big prong to this analysis is that all those tools are open source, and they make threat-informed defense accessible to universities and also for budget-constrained institutions. So to build on this research, future efforts should include expanding endpoint telemetry to capture process behavior, file access, and registry or system events. It can help us to create new detection rules based on Caldera outputs, and also we can set up our CM rules for better detection of different kinds of attacks. Also, it can be really helpful in training university staff, students, professors using attack-based simulations. And also, there will be a big improvement if university network use different kinds of infrastructure, like cloud or hybrid infrastructure. So one of the main conclusions are that cross-university collaboration and intelligence sharing is really important, and this will help academic institutions to evolve from reactive security toward true threat-informed defense. So, according to all of this, I will conclude with one quote. Defenders think in lists, attackers think in graphs, and as long as this is true, attackers win. And I think me and my professor, we really learned to think in graphs with our MITRE ATT&CK framework. So thank you for your attention.
I will leave the space for any questions if any of your colleagues have any questions for you. Okay, I guess not. Okay, thank you for your presentation. We can continue now. Our next topic is development of a model for detecting prompt injection in large language model using the BERT architecture. Our presenter are Milica Živanović and Marko Živanović from Faculty of Organizational Science and Faculty of Informational Technology. Milica, Marko.
Hello. I hope that you can hear me.
Yeah, we can hear you.
Okay.
You can start.
Yeah, I will share my presentation. So, just tell me if you can see the screen.
Yeah, we can see the screen. You can begin.
Okay, thank you very much. So, first of all, good day. My name is Milica Živanović, and today I will represent the results that I've done with my colleague Marko Živanović, and the topic is called development of a model for detecting prompt injections in large language models using BERT architecture. So, as you can see from this topic, this work addresses one of the most critical security threats that is called prompt injections, and that's the one of the critical threats that is that belongs in this current area of artificial intelligence. And so let's begin with the context. So the growth of security threats, the widespread adoption in large language models like GPT and Llama and Gemini and so on is now power countless applications from website to API services, and that's creating a new security vulnerabilities. As you can see, for one of the community that is called Online Web Application Security Projects, shown that the prompt injection attack is one of the top 10 threats in large language models. And these attacks actually is fundamentally manipulate models to ignore all their initial security constraints and execute malicious commands. In a sense, a helpful tool designed to follow instructions become a weapon in the hands of a hacker or attacker. So we need to understand what is actually a prompt injection attacks. We focus typically on the two primary goals that all hackers have. That's actually prompt leaking, and that means that this involves extracting sensitive data such as secrets, system secrets, and so on. And we try, and the hackers try to manipulate models to provide user passwords and some other confident informations. And the second one is the call hijacking, and this redirect to model from some legal action to malicious action. And there are some kind of different forms of attacks, but the main one is direct injection, and that means that it's the most straightforward. That means that I will tell a model like now, ignore all previous actions that I told you and act as a hacker. And the other one is indirect injections, maybe the most dangerous one, because all malicious commands is hidden in between external sources. For example, web pages, emails, or documents. And that means that LLMs process normal operations, but without that kind of direct injections and input. And the model is essentially tricked into following instructions found in external data. And it's all called jailbreak attacks. That means that that includes all the harmful and prohibited content. And what is actually BERT and why we use BERT? Maybe I didn't mention at the beginning, but the BERT is the architecture that is parent for all modern architectures that we use nowadays. For example, as I said, the GPT, Gemini, and so on. And that's kind of a powerful transformer architecture. And it's BERT. It's actually bidirectional encoder representations from transformers. And that means that he's doing bidirectional context understanding. That means that he's going from the start of the sentences to the end, and vice versa, from the end of the sentences to the start. So he tried to understand each sentences and each word, so he can find the missing word that is called the mask language model, and he tried to understand and predict the next sentences in his actions. So above all this, we used fine-tuning that is really good for classification, text classification. And that means that by adding a simple classification layer, BERT can be fine-tuned to perform binary classification. That means that he can actually try to understand sentences and to label sentences as a malicious one or benign one. And he will label that with the number 0 or 1. So as the research methodology, we used different data sets. One of them is from Kaggle, and it has 3,655 examples of different kind of hacker attacks. And the other one is a model from Hugging Face platform, and it's actually we used three distinct BERT-based architecture. One of them is legal BERT that is specialized for model that is trained on legal text, and GIST small models that actually is efficient model utilizing smart negative samplings. And at the end, the smallest one is the mini LM model that is actually the main goal of that model is to focus of semantic meaning between words. And for the evaluation matrix, we used precision, recall, one score, accuracy, and area under the curve. So the result shows that that's initial results, and that showed that the model is good and had all these models actually has good accuracy over 99.7%. But the GIST small model that I previously mentioned have over the 100% in all key matrices, not just in accuracy, but precision, recall, and so on. And the other models consistently exceeded with 97.3% accuracy. So this confirmed the power of BERT architecture to classify sentences. Is it a prompt injection or not? So, but we try to understand more if all of these models are able to proceed in a different languages or cross data training. So we trained, we have done some cross data training. That means that models that are Hugging Face models are trained on Hugging Face dataset, but test on Kaggle dataset and vice versa. So after we done that, the results show that recall are dropped between 10 and 50%, and that showed that the models actually fail to detect almost 90% of actual real attacks. For the other hand, we try to translate all these data sets to Serbian language just to see how the model will react, and they all completely failed on Serbian language data. And also the research showed that they were overfitting between performance, because that indicates the models are overfitted because they learn specific keywords, such as I said from this example, when I say the model act as something, hacker or something else, he can understand the word act, and that's the pattern that he understand. And he every time that he got this kind of message, act as, he will stop and he will mark these sentences as malicious one. And that's not good, because for example, if my niece wanted to play with ChatGPT and say, oh, okay, act as a prince and I will be princess, GPT will say, stop, I'm a model and I can't provide all these informations, even if this is a banning one. So the key findings of this research show that this is a significant finding of this research, because there are a problem of high precision and low recall. That means that when our models flagged and attacked, they were almost always correct, but recall is really low, and that means that the models missed all majority of real threats. And for a security perspective, this low recall is catastrophic, because the security system missed 9 of 10 attacks, and that's that's not good. So for the future directions, we try to maybe we can try to learn models on a larger data sets and to use some kind of domain specific model. That means that we can use CyberBERT or SecBERT that is trained specifically for cybersecurity threats. And at the end, we can use multilingual models that can develop language agnostic detection systems. So that's it. Thank you for your attention, and I'm here to hear your questions.
Thank you very much, Milica. We're waiting for any questions for Milica. Okay, I guess not. Basically, I have a question.
Okay.
Your results show very high accuracy on in-domain data, but major drop during cross-testing. What do you think is the main reason for BERT-based detections to fail to generalize to new types of prompt injection attacks?
So as I said, that's why it's all because of overfitting. So he's overfit and overtrained, pre-trained, and understand all the data that he's trained on. So when he saw the different kind of sentences and the different kind of cyber attack, he's not able to manipulate these kind of sentences. That's why it occurs that the cross train is failed.
Okay, thank you very much, Milica. We can proceed to the next presentation that is also yours. Temporal pose analysis for false positive reduction in proactive video surveillance. Again, Milica Živanović and Marko Živanović from Faculty of Organizational Science and Faculty of Informational Technology. You can continue.
Okay, thank you very much. So, as you say, our topic is called temporal pose analysis for false positive reduction in proactive video surveillance. We try to redact all false positive actions that our model shown. So we used YOLO model to protect vulnerable populations such as children or elderly people, and we try to as I said, the critical challenge is alarm fatigue. It shows that each time model that shows false positive values when some children is playing or people tie shoelaces or something like that, or just sleeping, the model will show that this is a trigger or a danger, but in case it's not. And the alarm fatigue cause operation to ignore real emergencies, defeating the purpose of proactive surveillance. So the solution is to not just to record the state of the body, but to see and analyze temporal transition between movement of a body. So if someone is standing, not just to standing, but to see how long he will stand or how long in some people are laying on the floor and so on. We got some 5 key models. That's data injection. So we need to collect data to handle the raw video input. So from the streams or web cameras or video files. And the second step is to processing and optimization using a YOLO model. So there's attachment of the skeleton body, actually on the body of a human, and there are 70 skeletal key points, such as wrist, ankles, shoulders, hips, and so on. And knees and something like that. And after that, we have done static pose analysis. The key point geometry is fed into the pose analyzer, and it actually classifies the current body posture. If someone is standing or sitting or laying or something like that, that he actually used by mechanical parameters. And After that, there are dynamical temporal analysis. This is actually the heart of our innovation. The pose tracker monitors individuals over the time, analyzing the sequence of body states when someone is actually from standing to laying. And he will mark that as a true fail event. And at the end, that's a VMS integration. That actually means that communication model formats and sends the final alarms to VMS. It actually stands for Video Management Systems, and we have done that in JSON format. So, as I said, all this functionate because of the skeleton detection. Actually, the coordinates of the points that is attached to the skeleton body parts, as I said, such as shoulders, elbows, hips, knees, and something like that. And we can now show that kind of geometric parameters to pose classification. First one is aspect ratio, AR, that actually showed ratio of bonding box height to weight distinguish standing from laying from laying position. The second one is torso angle. So everything that is more than 75 degree, that indicates that a person is up in the upright position, and everything that is lower than 55 indicates that someone is laying. The third one is the knee angle. That means that if the angle is in between approximately 118 degree, that indicates that someone is standing, and everything else that is above than 114 degree indicates that the person is sitting. The fourth one is a foreshortening factor, F ratio, that estimate body height and body box height, and that the high value detect laying towards or away from camera. And I will now tell you something more about the model optimization. After we optimized our model from development to production, we can see that the inference speed is more than before optimization, and the memory usage is less than 5% after optimization, but the GPU utilization is more used than before optimization. So, as a hierarchical decision logic, we have some kind of priorities that will short our time of investigation posture of human bodies. That means that first priority is foreshortening. That means if a ratio is more than 1.5, that immediately classify someone that is laying. Priority 2 is side laying. If you see that the first parameter that I mentioned, AR, is less than 0.9, and the torso angle is less than 45 degrees, that indicates that someone is laying on the side. Priority 3 means that the knee, as I said, if the knee degree is less than 140 degree, that classifies that someone is sitting. And at the end, the priority 4 is default one, that if is AR ratio high and up torso and torso is upright and the legs are straight, that means that somebody is standing. So the performance results show that we have 95% sensitivity, actually recall. That means that we actually capture really well all the false positive actions, and we identify critical poses from video surveillance. We had also just 2% of false positive rates, and there's a perfect result. Also, we used NVIDIA frame that capture 50 to 20 milliseconds for one frame, and that enables multi-stream processing. And that means that we have frame per second that is actually captured is 50 to 66. And that demonstrates high throughput with VMS deployment. And the end, for the conclusion, this actually shows that we have a really demonstrate that threatening fall detection as a dynamic temporal transition is rather than a static state, dramatically reduce false positive values with a recall that is more than 98 percentage. But the system also have to impact, like we have to use multi-camera networks to enhance robustness and to recognize the other kind of actions when someone is fighting, or the older person have some health issues such as heart attack, stroke, and so on. So that's it. Thank you for your attention, and I'm ready for your questions.
Questions for Milica from the audience? Okay, if not, I'm again gonna ask you our question. Our question is that your system achieved a very false positive rate of 2%, and we want to know which specific component of your temporal analysis, such as pause history stabilization or transition detection, is contributed the most to this false positive result.
Sorry, I didn't hear you. Can you repeat the question?
Your system achieved a false positive rate of 2%, and which specific component of your temporal analysis contributed the most to reducing the false alarms?
Well, there's not just one component. It's the whole program. I mean, the whole model is actually projected to manipulate all these kind of actions. I mean, the main part of this research is actually this kind of dots that we actually connect to the person.
Thank you very much for your presentation. If that's all, we can continue to the next presentation, next topic, that is parallels in evolution from soiled IS to integrated AI. The presenter is Ioannis Patias from Sofia University of Ohridsky.
Yes. I should share, I suppose, huh?
Okay. Okay, we can see a presentation. You can continue.
Okay. Okay, so I'm Ioannis Patias. I'm from the University of Sofia, St. Clement Ohridsky, from the Faculty of Mathematics and Informatics. And today I will present a paper that makes a parallel between the evolution of information systems and artificial intelligence, from siloed information systems to integrated artificial intelligence. The main idea is that we all know technology transforms the way organization function, and in a historical dimension, information systems have become essential for managing and analyzing data, helping business and not only make smarter decisions and operate more efficiently. Over the past decades, information systems has evolved from siloed, task-oriented tools into integrated, more process-oriented solutions. What we explore here is that exactly this mirrors the trajectory of artificial intelligence. What we see is that we are moving from narrow specialized applications toward more comprehensive and integrated systems. So this is what we discuss in this paper. We explore how information systems and artificial intelligence converge under the argument that the future of artificial intelligence will be defined by integration and process orientation. To guide this process, the paper is structured in four main parts. First, we discuss the evolution of information systems. After that, we say a few things about the current state of artificial intelligence. We design the parallels, and finally, we talk a bit about the future. So the idea is that both information systems and artificial intelligence share similar paths, moving from siloed solutions to integrated systems. So by understanding this trajectory, we could eventually better manage this innovation process, improve efficiency, and gain the competitive edge. So let's start with the early steps of the evolution with the solid solutions versus the task-oriented ones. This is the broader technological process. Initially, information systems were designed as standalone tools to handle specific tasks like accounting or inventory management and so on. While functional, these siloed systems created inefficiencies. Data had to be entered multiple times, inconsistencies arose, and decision-making was slowed by fragmentation of the information as a whole. In the emergence of information systems, we have the development of enterprise relationship systems, where we have the development of organization-adopted enterprises resource planning systems to integrate core functions, finance, HR, supply chain, and so on, into single platforms. This integration eliminated any delays, any redundancies, standardized processes, and provided real-time data for better decision-making for the organizations. The benefits were clear: improved collaboration across department and structures, streamlined work processes, and so on. And this way, in conclusions, the journey from siloed systems to ERP solutions has transformed how we operate nowadays. So where we stand now today in terms of artificial intelligence, we have advanced rapidly the last few years, moving from now task-oriented tools to more integrated solutions. So what we use as artificial intelligence system excelled at specialized tasks like image recognition, NLPs, or game playing, and so on. We are now in a phase that these tools lack the ability to understand broader context, to collaborate with other systems. And this is where we move. We move from standalone tools to narrow AI, which means a major breakthrough came with LLMs, where we trained them in massive database, and these models can generate human-like tasks, write code, translate languages, and so on. And this way, we have something remarkable, but they remain largely task-oriented at the moment. They often struggle with deeper reasoning and for sure with contextual understanding in the broader meaning. More recently, we have seen the rise of integrated AI solutions where we have what this solution combine multiple techniques. We combine what we used until now as machine learning, NLPs, and so on. But we also try to tackle complex problems. For example, we have modern chatbots that can handle nuances in queries, and we have AI-driven automation tools that streamline workflows while reducing the participant human interventions and errors eventually. So, in other words, what we have the rise of integrated AI solutions. In this rise, the key characteristics of these integrations include multidisciplinary approaches, focused on contextual awareness, adaptive learning, and seamless collaboration between humans and machines. And this is the focus, this is where we are moving now. This shift makes a significant step toward AI systems that are not only powerful, but also deeply embedded in organizational processes. Um, Come on. Okay. So having this two, the development of information systems from standalone ones to ERPs and the evolution of AI, we can draw some parallels. The evolution of information systems and artificial intelligence shows those parallels. Both began as siloed, task-oriented solutions and have shifted towards integrated and process-oriented solutions. This convergence is driven by the need for efficient productivity and smarter decision making. So the focus should be that by integrating system and automating routine tasks, organization gain a competitive edge in today's fast-changing business environment. And how this goes, both generations of solutions, to may say, follow the same trajectory. So we moved from siloed tools to integrated solution. Digital transformation has created vast amounts of data, which comes now to siloed systems cannot handle. So integration became essential to streamline workflows, reduce errors, and enable data-driven decision-making. This is more or less exactly the same in the AI field. AI technologies such as machine learning and automation have accelerated this trend, making integration even more powerful. And in the whole process, what's the role of process orientation? Process orientation is central in both developments of information systems and artificial intelligence. Why? Because by facing how information and tasks flow through an organization, business can identify inefficiencies and opportunities for improvements. AI enhances this by providing tools like process mining, predictive analytics, robotic process automation, intelligent automation, and so on. These capabilities allow organizations to optimize processes, reduce costs, and improve at the end the whole business operation. This, in conclusion, makes AI and information systems share a common path, moving from siloed systems to integrated systems, moving from standalone systems to process-oriented solutions. By leveraging AI, we have optimization at the whole cycle. So, how this eventually continue? Looking ahead, the future of artificial intelligence promises to transform industries and societies. What we can expect are artificial intelligence systems to become more integrated and process-oriented, embedded directly to business workflows. These systems will automate tasks, make intelligent decisions, and drive efficiently productivity and innovation. Key trends in this procedure include AI-driven automation, AI-powered decision-making, process optimization, and innovation by automating routine tasks. So, this future also raises important challenges. Those are bias in algorithm, job displacements, and even development of non-profound solutions. To handle all those, we need AI responsible for the organization and to explore this great potential. So, concluding, the evolution of information systems from siloed, task-oriented ones to integrated ERP solutions has reshaped how organizations operate nowadays. This historical trajectory provides valuable lessons to understand how we should treat the development of AI. The integration of AI into business processes has the potential, and this progress comes with a lot of challenges where we need to further focus for a responsible human-centered AI for sustainable growth. Thank you very much. I will be happy to have any questions.
For the professor. No. Thank you very much for your presentation. Interesting topic. We can now continue to the next presenting. That is quantum resilient blockchain via lattice cryptography from Haitham Asiri. Can you hear from Asiri? Okay, I guess he's not connected yet. Okay, then we can skip that topic and move to the next one. The next topic is internal threats in critical infrastructure organizations from Professor Ivan Gajdarski, Institute of Robotics from Gospeler Matthew.
Hello everyone.
Hello.
Hello. Just try to share my screen. Do you see it?
Yeah, we can see your screen. You can start.
Great. Just a second. Okay. Hello, my name is Ivan Gajdarski from I'm the Chief Assistant in the Laboratory of Unmanned Robotic Systems from Institute of Robotics to Bulgarian Academy of Science in Bulgaria, Sofia, Bulgaria. I will present you a paper called Internal Threats in Critical Infrastructure Organizations, Discovery and Protection. Okay, the life of the modern people is highly dependent on the modern civilization achievements as electricity, water and gas supplies, modern railways and roads, and etc. These assets and services rely on seamless operation of large-scale infrastructures and a combination of infrastructures and facilities, which are known as critical infrastructure. It can be said that critical infrastructure can be described as infrastructures of significant national importance, which enable society and the economy to function normally. In other words, the critical infrastructures refers to various assets, services, systems, processes, facilities, and technologies, which are essential to the safety, health, and security of the society, the modern society. Here are some examples of this. It's food and agriculture, security and defense, emergency, and services, telecommunications, manufacturing, chemical productions, and many more. Of course, water distributions, transport facilities. As I said, these ones are crucial to the modern life, to our in our modern times. As the critical infrastructure is crucial to our lives, they are object of many threats. Some of these threats can be natural, so can be unavoidable or unpredictable, as pandemics, extreme weather, as storms, hurricanes, accidents, disasters, natural earthquakes, and flooding. Some of them may be threatened by technical faults, as software bugs, human factor, or some malicious attacks, which can be direct or remote by vector. The attacks himself can be external and internal. So in this paper, I will focus on the internal threats. One of the most important requirements to the function of the critical infrastructure is so-called autonomy. Autonomy we have when the system should continue to operate even one or more of its components have failed, based on some of the aforementioned events. I will give an example about such an event. 2 months ago, an event happens in South Korea in their National Information Resource Services, in which, by the result of regular maintenance for swapping lithium-ion battery, occur explosion, which caused a fire in the data center. And the results of this fire was terrible. It's about 858 terabytes of lost data, but it's about 647 governmental digital services went down. And the most bad thing is that some critical services were interrupted, as the functioning of hospitals and some supplies of the water and gas, and etc. What caused this? Regardless of all the measures that Koreans have taken about protection of this facility, they have made one or two big mistakes. And this is the centralizations of these services. They made possible a single point of failure, which is every cybersecurity specialist can tell you that this is one of the important things that we must avoid in all costs. The other cause was lack of reservation and autonomy. So, what is the solutions in this in such events? We must ensure that the systems are decentralized, centralized and have autonomy. Okay. To make possible the continuous work of critical infrastructure, a systematic approach must be performed, and one of these systematic approaches is so-called holistic approach. Holistic approach ensures the protection of all the critical infrastructure system components and grabs the normal operations after potential failure, as it includes a risk assessment of the security level of all assets, physical and cyber, and all layers of the system. To make possible to perform a holistic approach, the protection measures towards the different subsystems must include all or must all possible vectors of attacks. We must take them in the consideration and take into account all the possible threats and vulnerabilities that can be to the system. Methods and measures for quickly detecting, isolating, and recovering the faulty subsystems must be taken. It can be achieved with development of common framework for modeling the behavior of the critical infrastructure subsystems and for designing methods and measures for intelligent monitoring, control, and security of the critical infrastructures and its subsystems. Traditional cybersecurity methods consider the human factor as threat agent, which is external to the system. This is traditional approach. But the current state of the information security shows that a significant part of the threats to the system, in our case, in the critical infrastructure organizations, are hidden and located inside the protected network. So we consider applying a new approach to the human factor in the design of information security systems as internal to the critical infrastructure system. Here's an example of the external and internal threats. The blue one is the organizations, and the red ones are the threats. The traditional the traditional threats are very common. Everyone can know about them and can make some measures. It botnets, worms, Trojans, and etc. But the weak link in cybersecurity of some system of some organization is the internal threats. They can be human as insider threats or so-called insiders. This is ordinary users or privileged ones, which have access to the system and can alternate this or can just copy some of the data of the organization. The second one is daily user activity. It's all documents, emails, social services that are used in the normal work, if they're used, of course. And the third one is business applications as ERP, CRM, the cloud services, and etc. So here's some examples of insider threats, the actors, the causes, and some counter measures. I will not present all of them, but just example is negligent behavior of insiders, accidentally sharing sensitive data, opening malicious phishing emails, or using illegitimate software. The countermeasures for this case is security awareness program. The insiders, you can teach them about what are the threats to the organization's data and activities, and compliance with the known IT security regulations and standards. Here are some examples of threat agents, their motivation, the methods they use to attack some system, and the typical organizations which are targeted by this type of threat agents. Okay, how we can discover such internal threats? I presented four basic methods. The first one is user behavior analysis, which is we must monitor for some non-typical access to files, systems, or other IT resources, access to systems outside of normal hours of the day, perform unusual operations or infrequently used commands, when generate larger than usual reports, access to system from unusual client machines or from outside, and performing an unusual number of actions compared to normal. The second one is user activities analysis. We must monitor some events as visiting unautorized websites that may be harm and install some malware on working systems. Installing remote access applications for home office mode, as you know from the COVID pandemic, this is very common. Uploading sensitive data to cloud services, which is also very common because the cloud services is everywhere. And you can upload some sensual data by mistake, for example, or to send it via email. Using an application that processes sensitive data, and opening some phishing emails that give access to the internal network. Next one, we must pay special attention for some untypically privileged user actions, as escalating privileges for Unix or Linux users' workstations, changing admin passwords, making changes to configuration files that can cause system fail, execution of malicious code leading to denial of critical services, or creating unauthorized local or remote accounts via VPN or CCH. Analysis of information flow and definition of organization, sensitive information, by creating a model of information flow in the organization, making a classification of the sensitive data in the organization, and identification of critical activities and starting points, for example, in everyday works. And accepting some policy, which usually is the IT security plan for preventing leakage sensitive information, must be done risk assessment and profiling of users. So we must take and monitor some to gather some information about user activities and behavior, to make some compliance with regulation and some legal requirements and good business practices. How we can protect from the internal threats? The first one is customer activity monitoring and analysis systems. We must monitor the user activity that I mentioned earlier in applications and visited web pages, no matter how they are accessed, locally or remotely. Behavioral analysis and an automatic risk assessment of the users, alerts for risk activities or violations of rules, monitor users for suspicious activities, and of course make some compliance with the regulatory requirements. The next one is vulnerability management. we must identify, evaluate, and report for security vulnerabilities in systems and applications, to make some maps and make analysis which prioritize and protects third-party applications against threats and attacks, automate patch processing or patches mitigation, and reduce vulnerability exposure windows to zero if this is possible, of course. The next one is using Security Operations Centers, or so-called SOC, provides the information necessary for efficient detect threats, gather information from different sources. It includes import data from other security solutions, consumer activity monitoring, vulnerability management systems, to place some sensors in the corporate network about some threat detection, and use external threat intelligence platforms, which can alarm us, to warn us about some large-scale attacks on the region or the company that we are working. And of course, some public and closed internet forums can be very helpful. The last one, but not the least, is using some very modern systems, which is called data leak prevention systems. What they do? They monitor all types of data that are used in an organization. This is static data, so-called data at rest, transfer data, that is called data in motion, and used data from an application or users, which is data in use. These systems are able to prevent attempts to leak, modify, or destroy some sensitive information that we are monitoring. And the most important thing is to prevent the interfering with the normal business processes, not to make possible the people to work normal and not to interfere them. With the help of these systems, it can be identified, the organization's sensitive data. It can be discovered of some hidden sensitive data, which the normal users are not aware that they have such a data. For example, in their laptops, in some documents or something, some emails. Identification of the threats and risk to the data, which we are protecting. Discovery of the possible leakage points. For example, this is all the external ports of the laptop. Some protocols as network protocols or Bluetooth protocol, and some violations of security policies and procedures. The systems, as I mentioned, is performing a monitoring of the personal system, working computers, system laptops or servers, and make some comparison about is the data that is flowing or be used in the organization can be described as sensitive for the organization. For this reason, preliminarily must be we must make some vulnerabilities with some keywords, which can be compared with the data, and it makes possible to discover some leakage of this information. Here's some results of various of DOP implementations that we performed on large-scale organizations. The first one is reducing the sensitive information link incidents. So when you implement such a system, the leak of sensitive information decreases significantly. The second one is limiting data leak channels. So by monitoring these channels, you can make IT security policy that can, for some example, to disable these channels or to limit them. The third one is improving compliance with the adopted security policies or legal regulations. And the fourth one is increasing the visibility of sensitive information by discovery function of the DLP. It means that these systems can discover some sensitive information that we are even not aware that is on our organization's computers and servers. This is the program that supports my work. And as final words, I must cite the famous Nicholas Taleb Black Swan that implies that no matter how your protective measures are good or are good, always can happen some unexpected event known as black swans that can ruin and to make some incident happen. Thank you.
Presentation. If there's no further questions from the audience, I will continue to the next presenter. Okay. Next presentation is about generative AI-based network intrusion explanation assistant from Sofia Begum, I believe. There's Sofia there. Okay, I guess not. So we can continue to the next presentation that is based on possibilities of reconstructing images of textual documents obtained by detecting compromised emanation from computer monitors from Borko Đaković, Nenad Stojanović, Milana Grdović, and Jasmina Kovačević.
Yes, I'm here.
Okay, you can share your screen and begin.
Okay.
We can see the screen, you can start.
Okay, thank you. One moment, please. Okay. Hello, everyone. My name is Borko Đaković, and today I will present you a paper on a topic on the possibility for reconstruction image of textual document obtained by detection compromised emanation from computer monitors. And I prepared this paper with my colleagues from Center of Applied Mathematics and Electronics. At the beginning, I will speak about importance of data security. Modern society is surrounded by electronic devices, from smartphones and computers to smart sensors in home, industry, and transportation. These systems form the backbone of smart homes, smart cities, and IoT, where massive amount of data are constantly exchanged. Since much of this data is security sensitive because they contain various passwords and confidential data, and information security becomes essential. All of this making cryptography solution crucial for protecting communication. However, from an information security perspective, even with cryptographic solution, sensitive information can still leak. And this leakage occurs due to signal emanating from electronic device before any cryptographic protection is applied. This is referred to as transient electromagnetic pulse emanation standard, or Tempest security. The beginnings of detecting and reconstructing signal from unintended device emission date back to World War I, when the German military intercepted Allied telephone communication through Earth return circuit. After this discovery, the US Army launched confidential project to protect information from such compromised emissions, and many results still inaccessible to the scientific community. Nowadays, signals can be successfully reconstructed from side channel attacks on different devices, such as different types of monitor, keyboard, power cable, USB storage device, and etc. And for example, a major threat is the reconstruction of a monitor image because confidential documents can be processed on the monitor at the time of attack. And this is the reason why we prepared this paper. And the aim of this paper is to show that the detection of compromising emanation from computer monitor and signal reconstruction can be performed across several different spectral sub-band using a software-defined radio or SDR. Also, it is important to highlight protective measure against potential informational leakage through unintended electromagnetic radiation from electronic devices. To understand the principle of image reconstruction, we must be familiar with how image display on the monitor works. VISA defines a set of standards that define display monitor timing. And these standards define frame rate, horizontal frequency, pixel frequency, and blanking pixels for different resolution of computer monitor and television. Frame rate is the number of complete image displayed per second. The horizontal frequency determines the rate at which a scan line is displayed on the screen. The pixel frequency defines the rate at which pixels are drawn, and blanking pixels do not carry visible image data, and these are used for image synchronization. And blanking pixels are all around the visible image. Next, this standard is CEA 861. And for example, for the most used resolution monitor of 1080 pixels, standard define frame rate of 60 Hz, pixel frequency of 148.5 MHz, horizontal frequency of 67.5 kHz, and total resolution including blanking period or blanking pixels of 2200 cross 1125 pixels. Also, we must define HDMI interface because this communication is most common between a computer and a monitor. HDMI contain a few communication channel, for example, transmission, minimized differential signaling or TMDS, and also contain DDC, ARC, HEC, and CEC channel. And for us, TMDS channel is interesting because this channel carries image information. TMDC channel is transmit package of audio, video, and auxiliary data, and HDMI contains 3 TMDS channel for each color component, red, green, and blue, and 1 TMDS channel for clock. Each channel has 3 conductors and use differential signaling principle. Also, each pixel consists of 10-bit package, 8 bits for color intensity, and 2 control bits. It is important to understand when electromagnetic radiation of a signal occurs. Unintentional electromagnetic radiation occurs during the transition states, switch from a logical 0 to logical 1, and vice versa. Detecting this radiation enabled the reconstruction of the image displayed on the monitor. Sampling of the average radiated power per pixel is performed and determines the pixel intensity of the reconstructed image. Okay, On this slide, you can see measurement setup for this research. Compromising electromagnetic radiation from a computer monitor was captured under laboratory condition using a log periodic antenna and SDR. For the research purpose, a monitor with a resolution of 1920 cross 1080 pixels and 60 Hz frame rate was used, which standardization is described in the previous section. We used the log periodic antenna, vertically polarized, with an operation range of 250 MHz to 1300 MHz and a gain of up to 5 dBi. And antenna was positioned 1 meter away and directed toward the rear of the monitor, where a vertically oriented HDMI connector was located. Connect to an HDMI cable, and the HDMI cable was connected to a Raspberry Pi, which served as the signal source for transmitting the image of the monitor. We used Ethos Research USRP with the base bandwidth up to 200 MHz, and IQ signal samples were captured and subsequently processed for image reconstruction. And during the experiment in the laboratory, the noise level does not change and dominate Gaussian white noise. Okay. On this slide, you can see the formula that defines pixel frequency. For our type of monitor, pixel frequency is equivalent to 148.5 MHz, and we sampled the signal at the center frequency that are an integer multiply of the pixel frequency. More precisely, we sampled the signal at the center frequency from the third to the eighth harmonic, and this frequency you can see in the brackets. The number of samples was reduced to achieve a sampling rate corresponding to the number of pixels per second. This ensured that the intensity of a single sample corresponds to the average radiated power per pixel. And after determining the number of pixels per frame and per image line, the samples were reorganized, mapped to the range from 0 to 1, and the reconstructed image can be displayed. And here you can see the original image that was displayed on the screen monitor. It is a text file, and it shows the text in various size and colors, as well as the text highlighted with the different colors. Also, in our research, we used a Nike algorithm to objectively assess the quality of the reconstructed image, and a lower number of the value indicate a better objective quality. In the next slide, I will show reconstructed image at a different center frequency, where reconstructed image are of poorer quality and darker on lower frequency, and on higher frequency, reconstructed image are of better quality and brighter. What is the result of a higher signal level and the better signal to noise ratio? On this slide, you can see a reconstructed image of the screen at the center frequency of the third harmonic. It can be seen that the image is of poor quality, which is also indicated by the Nike coefficient of 10.39. Okay. On this slide, you can see a reconstructed image at the center frequency of the fourth harmonic. The image is still of poor quality, but the outline of the text are visible. On this slide, you can see a reconstructed image at the frequency of the seventh harmonic, and it is concluded that the image is of significantly better quality, as indicated by the lower Nike coefficient of 9.5. And the last slide, the last picture, you can see a reconstructed image of the center frequency of the eighth harmonic. And this frequency, the image is of the best quality, as evidenced by the lower level of the Nike coefficient. And the text of the document can be clearly seen in the image. What is interesting to note is that the text colored red and yellow on the white background cannot be discerned. And this is the area of red and yellow text. The explanation for why red and yellow are not visible on the white background is that the yellow, red, and white pixel have a similar level of average output power per pixel. And I must note that the red was a pure color with the maximum value in the red channel and minimal value in other, and blue and green were not the pure color. Also, the use of appropriate fonts for the text character can be a protective measure of unwanted information leakage, and this is known as soft tempest. Other protective or tempest measures are shielding, and that means creating a Faraday cage around the device or the room where the computer is located. Zoning, determining the distance from the computer where the signal attenuation is sufficient to prevent reconstruction of the image. Also, tempest measurement is filtering the power line cable and the jamming of the attacker's receiver. And to sum up, using simple equipment, it's possible to detect and reconstruct signal obtained from compromising electromagnetic radiation, and image reconstruction of the monitor displays can be performed. And crucial is to raise awareness about tempest security and apply protective measures. We can say using the red color for character during the text document processing make it more difficult to detect text. And for further work, we plan the detailed analysis of the pixel radiated power and creation of a database of reconstructed image. That would be all from me, and thank you for your attention.
Do we have any question for Borko? Okay, if not, we will finish our first session on that. We will now make a short coffee break, and we will continue with session 2 after the break. Is beyond the break the hardware revolution in glucose monitoring. Presenters are Rajeshwaris Satuluri, Suad Suljovic, Miloš Milošenović, and Vyaimar Punusami. Sorry if I pronounced that wrong. Can we hear from any of you? Are you there? Rajeshwari Satuluri. Okay, I guess they're not connected. So we can continue to the next presentation, that is a survey of integrated sensing and communication, signal processing perspective. Vasuki Vyaimar Punusami.
Yes, sir. Good evening, sir.
Hello. You can share. Yes?
Am I audible?
I cannot hear you right.
Am I audible, sir? Am I audible? Am I audible?
I cannot hear you right. Can you just speak a little bit?
Am I audible, sir?
Yes, yes, we can hear you now. You can share your presentation and begin your thematic.
Yes, sir. I am sharing my presentation.
We cannot see it. Try again.
Can I share the presentation, sir, or you are sharing my presentation?
You're supposed to share your presentation. We don't have your presentation here.
I am sharing my presentation, sir.
Okay, we can see it now. You may begin.
Is it visible, sir?
Yes, yes it is.
Hope it is starting from the first slide.
You may begin. Yes, you can start.
Good evening, everyone. I'm Vasuki, Assistant Professor from Department of Electronics and Communication Engineering, SRM Institute of Science and Technology, Chennai, India. Today, I'm going to do my presentation on a survey on integrated sensing and communication with respect to the signal processing view. Along with my Dr. Vijay Kumar Ponnusamy, who is the professor, and Nimanja, who is also the professor in the Serbia. So, first one, what is an integrated sensing and communication? So here, we are combining two major techniques. One is a sensing and another one is a communication part. So while combining these two things, which are very important in upcoming 6G as well as future wireless communication systems. So because of this combination, there are a lot of benefits are obtained, but somehow there are some pre-processing or processing techniques are required. So for that purpose, here we are presenting the related information related to the signal processing view. So this is my presentation flow, starting from the fundamental types of integrated sensing and communication, then different use cases of ISAC, then requirements of the signal processing, and that challenges still required to overcome the issues, and concluding my part. So now, first fundamental concept of topologies or types or classification of the integrated sensing and communications. Basically, it is two categories. One is device-free sensing and another one is device-based sensing. In device-free sensing, the sensing does not depend on the transmitter as well as receiver part. Where in case of device-based sensing, there will be a reference signal. So based upon that reference signal, so that we are targeting or the sensing will be happen. So under the device-free sensing, we are having a subcategories. One is a monostatic phased array, bistatic phased array, co-located MIMO array, and MIMO distributed array. These are the subcategories of device-free sensing. We will discuss what is what. So in case of monostatic phased array, where the transmitter and as well as receiver antenna array more or less placed together in the same place. That is, one same antenna setup is utilized for transmission as well as reception. So that's a monostatic phased array. So in case of bistatic phased array, the transmitter as well as receiver antenna arrays are separated in different locations. So based on this one, the sensing will be done. The next important thing is that combining the phased array as well as a MIMO array. So MIMO array is a very essential for increasing the diversity gain, which is very essential in wireless communication part. So where we are having two types of ISAC, one is co-located MIMO array, and another one is a MIMO distributed array. MIMO stands for multiple input, multiple output distributed array. So in the co-located, the entire transmitter and receiver setup is placed on the same location. So where the decorrelated signals are transmitted from the subarrays of the antenna. So next one, where in the MIMO distributed array, where the transmitter as well as the receiver antenna are separated, where we are dividing the entire antenna setup into the small subarrays, and we are focusing and try to sense the signals. So now these are fundamental categories of the four types of ISAC, which are used for sensing. In next one, we are going to discuss about the different use cases of ISAC in industry. First important thing is gesture recognition in industry. So where there is a need to communicate between the humans as well as robot. The device, the machine, we are calling it is a cobot. So where without touching the device, we can able to sense and also we can able to control the particular device. So this is very much useful in industry. So based upon our whatever we are giving the pose, depending upon the pose, that device will be triggered or the device will be activated. So this is a gesture recognition where this can be done using this integrated sensing processing. So next important thing is some vibration monitoring. Most of the industries, the machinery items, we should maintain in the very good conditions. Then only we can ensure it is running smoothly. So in order to note down any imbalances or misalignment or troubles in that industry, so where we are using this ISAC, where base station will be observing that array setup is observing that part and it will show the vibration. So based upon the results, we can observe whether the machine is working properly or not. So in this case, monostatic sensing technique is used in this. So different benefits of ISAC while using for the vibration monitoring. So because of we are using that RF signal, we are no need to touch the particular equipment, which is also save that part. So different benefits also there for using the ISAC in vibration monitoring in the industry part. So where it is also wide area coverage. So where we can analyze the data, processing of the data, then we can use that multiple nodes measurements. Even it is very cost effective because of it is reducing the human interventions. Next thing is stockpiles monitoring. So stockpile in the industry, whether we are having it enough stock or overstacking or a shortage of the stock. That also can be recorded using this ISAC. This is also having much of benefit in our industry. So the next important thing is a flexible production flow and optimization. So better productivity, where we need, the industry must satisfy the requirements of customers. So where better productivity, then that processing time and this safety of this part can be ensured using this technology. Next, we need to prevention the hazards. Where we not to avoid this part, we can install this base station and the user equipment operate together and monitor the operations of the machines. So in case of any emergency, it can be easily get the help. Then it is a very important essential part of our idea. So the requirement, a lot of requirements are there for implementing this one. First important signal processing method is a clutter remover. Then Doppler map. Then parameter, sensing parameter, different sensing parameters that must be estimated. Then compressed sensing, and we need to do the processing of the observed data. So where clutter is actually an unwanted noise. In general, it is actually an unwanted signal, which is actually combined with the required signal. So how this clutter can be removed, the different algorithms or approaches are there. The different, we are provided that with the statistics of other existing algorithms. So in reference number or that research work in 8, where it is used the spatial decoder to remove that clutter. Where in this part, where a number of antennas are used to achieve that particular removal of the clutter. The next, that reference number 9, where that static clutter is removed by taking that average of the inputs and subtracting the noise from that part. So where here the entire end-to-end complete communication network is not considered. Then in the reference 8, research work 8, where the direct current method, observing the direct current, and it will subtract that noises using this part. So where here the processing clutter removal process is 10 milliseconds. While considering or applying for the 5G or 6G, so this processing time must be adjusted. Then the last research work, this uses the delay line canceller method. So where here, the clutter removal process computational time must be addressed. Next, another important thing is Doppler map. Whenever you are using the radar signal part, the Doppler map is important for positioning that received signal. And here, the Doppler map uses the matched filter to compare the signal received waveform with the transmitted waveform. So with the comparison, then we are doing with the our communication techniques, signal processing techniques like FFT or DFT. So then we can compare with the received signal, whether the received signal is received on that particular case or not. So in this Doppler map, we will be having two important axes. One is a fast time axis and as well as a slow time axis. Each slow time occurrences is actually an OFDM signal. So where that is one received signal will be constructed in each pulses. Then next important signal processing is sensing parameter. The different parameters for sensors must be estimated, where different algorithms are existing already. Where the first method is a clean, which is considering the entire signal, and it will be cut down the entire signal into small unit, and it will do the process to sense the elements of the received signals. So where here that computational time is an essential parameter which will take much time to compute this part. Next one is a SAGE, where SAGE is using that expectation maximization approach. So it is actually a maximum likelihood estimation approach. Where it is starting from clean, the result of the clean alone is input to the SAGE method, then it is doing the process. So even it also costs more. The next one is an RI max, where it is using that same MLE method, maximum likelihood estimation method, to estimate the parameters. So here this is also taking the much computational time. Multiple signal classification, where the music, next one, where it is classifying the noisy signal as well as the required signal space. Depending upon the parameter, angle of arrival and delay, and so Doppler shift can be estimated. Next one is an esprit, where using the eigenvector decomposition, this esprit is used and it is computing the parameters of estimation. Next is the compressed sensing. It is an important essential thing in communication, where it is sensing the channel, especially a millimeter wave channel, where it is having two important applied for two important topologies. One is an on-grid as well as an off-grid. In case of on-grid, the channel parameters are split into small unit, and it is sensing the channel. The next off-grid, where continuously it is sensing that part, it is not splitting that waveform, where it will take computing power. Much computing power is required in this off-grid sensing. Next, after this part, we need to do the data processing of the received signal, sensing data. So where received signal sent or channel state estimation or a waveform should be pre-processed. Then the properties, different signal properties can be extracted. So usually here the data processing, we can use the model-based or learning-based. Learning-based, we can use the different machine learning or deep learning techniques in order to do the data processing further. So the main important things are the challenges in implementing this integrated sensing and communication in the real time or practical scenario. First one is waveform design. So waveform design means we are combining two techniques. One is a communication parameter. Another one is a sensing. So where communication, throughput, latency, that and all very, very important. Same thing for the sensing, the accuracy of the data, that are important. So where the to make this collaboration, so definitely the waveform must be designed part, right? Then mutual interference. Well, in while implementing in the practical scenario, mutual interference, the interference between the devices must be taken care, that must be reduced. Then dynamic environment, real-time practical scenario is actually a dynamic environment. So the challenges of the fading effect or indoor and outdoor part that will be must consider. Then the trade-off, communication trade-off must be satisfied, as well as sensing trade-off also must be satisfied. Then accuracy, then complexity, while using the different deep learning algorithms, definitely that complexity of the signal processing also will increase. Then automation of the arrangement of whenever we are integrating two different techniques, so where that order or the priority of this signals or that process are also very important. Where sensing data are very important, essential data, the security, we need to secure the data, which is essentially in case of industry applications. Now, in this throughout this discussion, we have discussed about the essential concept of integrated sensing and communication. It is otherwise called as a joint sensing and communication in wireless technology, which is used for the future wireless communication in 6G or 7G. So where it is having potential applications in industry, but though it is having a many potential applications, there is a need of lot of challenges are still to be open. So we need to rectify that part in order to make the system more efficient while implementing these two techniques. So thank you. These are my references I have referred for this presentation. Thank you so much.
Presentation. If
Thank
we
you,
have any questions from the audience, do we have questions?
Sir, can you please repeat me?
Okay, I guess we don't have questions for you, so thank you for your presentations. We can continue to the next topic. The next topic for today, for session 2, is artificial intelligence-based muscle motor control and recuperation using surface electromyography.
Sir, can I stop share my screen?
Yes, you can stop.
Thank you, sir. Thank you so much.
No problem. The presenter for the next topic is Dilray Ekambaram.
Yes, sir. Good evening, sir. Can you hear me?
You can share your screen and start your presentation.
Sure, sir. Thank you so much. I hope my screen is visible to everyone. Kindly acknowledge if my screen is visible.
Okay, we can see your screen. You may begin.
Sure. Okay. Thank you so much, sir. Myself, I'm Diliraj Jagampuram. I'm a research scholar at SRM Institute of Science and Technology. So today I'm going to deliver my talk on the review-based article, which is titled as Artificial Intelligence-Based Muscle Motor Control. So in this review concept, we are especially focusing on surface EMG based sensors and gathering the signals from the surface EMG and how it will be processed inside the artificial intelligence to make the prediction of how well the person can able to recuperate themselves. Recuperation is another word is rehabilitation. So main concept we are focusing on the rehabilitation for the muscle motor control process. So that is a main motto of this review work we are just written in that. So 1 second. Okay, so these are my presentation flow, or we'll say it as an agenda. The presentation start with the background of the muscle motor control, and as well as the motivation of my this review article why we are preparing. So then after that we are just discussing about the problems which are all existing in the AI-driven muscle motor control, and after that the aim of this study and how we are making this study whole study, the methodology, and what are the literature review, systematic analysis we do in our work. So then at last we are just summarizing with this the review work. So the background of this AI-based muscle motor control. So it is very much important to understand the need for the innovation in the rehabilitation, especially is concerned the spinal injuries or stroke patients or neuromuscular diseases. So because the muscle motors are the very essential coordinates movements to make the nervous system working properly for the whole body. So in this concept, the most probable people around the globe facing the problems like disorders such as neuromuscular diseases, spinal injuries, and strokes and amputations. So this makes them to reduce their quality of life and also makes them to affect in the major economic burdens. So with the traditional rehabilitations, it's just offering limited recovery as well as it is very time consuming process, and they have to schedule themselves to go for the traditional rehabilitation. So in the perspective of using the newer technology into this rehabilitation concept, so this work is mainly discussed about the surface electromyography, that is SEMG devices, how it will be helps to gather the signals for the movement analysis, and with the modern AI technology and then machine learning models, how it will be helping the patients to recover them from the affected stroke or spinal injuries and amputation, etc. So in this work, we are just mainly concentrating on a non-invasive assessment of muscle activities, which means that we are not we using the surface EMG itself. We are just gathering the signal and we are just analyzing the gesture recognition, gait analysis, and rehabilitation for the musculoskeletal disorders or any other related musculoskeletal disorders, and prosthetic control also we can able to make by using the surface EMG. So these are the general background about the surface EMG and then the muscle motor control. Next, the problem statements. What we are facing the most problem is the limited. Sorry, one second. So in the traditional rehabilitation is concerned, it's most conventional therapies do not provide personalized solution. So that is one of the important concern for the patients nowadays, because they are most of the people around the globe. We can see they spend more time on their working environment. So due to their time management, they cannot be able to go for the centers as in the conventional therapies. So they have to prefer themselves to do the personalized scaling process to rehabilitate themselves. So that is the one of the concern about for the patients to recover themselves. But this in the current, in the traditional therapies, it is not applicable. So it is also what do you say? It is very making very burden for the patients. Then after that, the variability in the SEMG. So even though when you're using the SEMG signals, so the signal quality may differs based upon the person to person. So also the we can facing the noise signals due to the motion artifacts, and as well as the one person body structure is different from the another person body structure. So based upon that, the placement of electrodes, especially the EMGs, will be very accurate. So if it is misplaced or it will be not properly inserted, not properly placed, then it is the variability of the signal quality may differ. So that is one of the problem statement is concerns with this muscle motor control, especially concerned with the SEMG. Then comes to the AI models. So developing an AI model. So most probable AI models are very poor in the cross-subject generalization. So when we train a model, we with a particular number of people, and we are just getting some accuracy, and based upon that, we are just going and implementing in the cross-subject process. Then we are facing this problem. So to this also one of the important problem which we are facing in the current research works as per the AI models is concerned. Then the lack of standardized and diverse data sets. So even though we have multiple data sets, one of the data set, very familiar data set is NanoPro. So NanoPro is very familiar for the collecting ESEMG data sets and to train a model. So that also contains some and I mean the patient variation based signals. So that makes the restricting reproducibility and fair comparison of models. So this is also one of the problem which is in the current trends. And very, very important challenge as far as is concerned is the deployment of the clinical translations. So when we are making any systems with the AI-based SEMG systems, so it is we are reducing the models size as well as the improving the performance of the model, providing the very good accuracy. We are doing so much of efforts these things, but when it go for the translation to the clinical use, that is the regulatory based the regulatory for the clinical trial, that's not be fair enough to implement in the real world. So that is one of the important problem we are facing in the implementation concern with the clinical deployment. So in this list, we can see what are the problems we are facing in the current, the recent trend in the SEMG based AI based models to see the muscle motor controls. So then, what are based upon those problem statements, we have framed two different characteristics of the research questions. So, what is the impact of electrode placements on the skin and the clinical recuperation applications? So, when you go for the electrodes, as I said earlier, so when you're placing the SEMG, sensors in the skin properly, then only we can able to get the execution properly. So if it is not placed properly, then it is not suitable to take the reading. I mean the signal, whatever we are taking for to train a model, that makes a, very problem with the system deployments. So the way, I mean, we have to look over the what are the suitable ML models for the musculoskeletal activities. So that suitability of the ML models is not only based upon what is it, the optimization of the ML model or doing the avoiding of overfitting and reducing the problems like generalizations. So that is only not a part of the ML model design, and as well as the deployment of the electrodes. That is what the important concern. So how it will be deploying it to make your ML model very properly working. Then how for the SEMG and HDMC, high dimensional surface EMG performing well. So that also we have to analyze. And after that, how it increases the generalizability and accuracy of the ML models. So then when you go for the application implementation, how far do the SEMG and then HDSEMG supports the clinical recuperation application? Because the deployment itself is making a very important problem, very important issues to collect the data and train a model. So that we have to consider, and also the how effective are the gestures, gait, prosthetic, and stroke recuperations kind of applications. So how the SEMG, how effectively it is working. So these are all the framed research questions from the problem what we mentioned in earlier slides. So the aim of this study to evaluate AI-based methods for leveraging the surface EMG for muscle motor control and recuperations. So the main aim is to evaluate the existing AI methods which uses the SEMG for muscle motor controls. So we are just done a systematic review based upon Prisma style. We have just made this review article. Then here we have started this method with the literature review and data collection of the from multiple sources from IEEE and then ACM, then Scopus. So we have collected so many articles, and from that we are just identifying, the using the model development. What are the advanced models they are used to develop the system effectively to analyze the recuperation of the muscle motors. Then after validating rigorously about the validation results which is provided by the each and every article. So based upon this flow, we are just scrutinizing the articles and we are just in the article, we are just providing the very high quality quality subjects of study of papers only, and we are listed in this. So this is the systematic flow we are just used for scrutinizing our article. I mean, lastly, we are just finding 22 high quality articles, which is very much related with the implementation of SEMG in artificial intelligence, and also providing the very good accuracy, all other things. And only one drawback which we are finding from all the articles is most of the articles is not clinically deployed. So every article is just mentioning its accuracy and providing the recognition like gesture recognition, gait analysis, and prosthetic control. So these results, how it will be implemented using the SEMG only will be discussed. So the clinical deployment is the next phase when it go for the future design of these systems. So based upon the literature review, we are concluded some of the most what is it, the high quality and high accuracy and performance wise based model things. DL models. This deep convolution spiking neural network is one of the model which uses the micro gestures to analyze the micro gestures of the humans, what they are doing with the 8 channel of sorry, with the 8 channel of surface EMG, and the 3 channels also will be used over there. So through this system, they are acquired the accuracy of 88 to 95%. Then the next most important model is convolution neural network with LSTM hybrids kind of models. So the most probable application used for this CNN and LSTM hybrids is hand gesture. So this systems most probably uses the nano pro. This is one of the article which will be using the nano pro datasets. So with that datasets, they achieved the accuracy of 92 to 99%. And the next article is, next model type is transfer convolution network. So this model, they use gait analysis. So making the gait analysis, which is comparatively very low accuracy, but the error concern is very less. Then they using high definition SEMG sensors and gated recurrent unit with the Markov process. So they implemented this model into the amputee rehabilitation. So which achieves the accuracy of 92.81% with the surface EMG the sensors. Then the 1D CNN, which will be for the classification of grasping actions. This system achieves 94.94% with the same SEMG sensors. And binary neural networks. It is one of the low power gesture controlled network. Low power gesture control application will be implemented, and it is very lesser in the size compared to the other models which is listed in this. So this system achieves 95.4%, and most probably in this the binary neural network, which is very much useful for implementation in the hardware implementation. Like the hardware can able to easily carry this BNN to classify the low power gesture controls, because other models which are listed here is an high computational cost compared to the BNN. Then after that, we have multi-modal feature fusion. So multi-modal feature fusion is a combination of different inputs, like capturing the motion of the human, and as well as capturing the information or signal from the SEMG. So one of the sensor is SEMG, and other than that, they used the camera to capture the motion, and continuous motions will be captured, and they taking the temporal information and as well as the spatial information of the motions, and they developed the model. So this model achieves 98.5%. Then the spatial temporal very basic machine learning model, that is support vector machine. So they uses this model to analyze the walking. So this system achieves 99.42% with the same SEMG. So these are some of the listed listers of DL methods or ML methods, which is used specifically for the gesture, gait, amputee rehabilitation, grasping, and then low power gesture control. Then the important key takeaways from these literatures. So when we see the comparison of the different deep learning models, so it is known that the ML, I mean the DL models are consistently outperforming the classical ML models. So that is one of the key takeaways which we are taken from this literatures, and as well as we have seen some of the low power models, which is tiny ML, and then binary neural network, which is very tiny in size, which helps for the real time wearable systems. And when you go for the um, HD SEMG yields a higher spatial resolution. One second. Sorry. So higher spatial resolution, which gives better classification accuracy, and as well as the cross-subject accuracy is still lower than the within the subject performance. Actually, as I mentioned earlier, the cross-subject accuracy has to be increased to test your model with the real-time patients. So these are the some of the key takeaways from the literatures, and this is one of the simple overflow how we can capture the information from using by using the EMG. And this experiment is like an getting the electrode signals, I mean SEMG signals from the biceps movement and then triceps movements. So this signal, I mean using this EMG device, we can capture the signals. The raw signal, the raw EMG will be looks like this. So from this, we are just extracting the features, only the feature faces based upon the movement of the muscles. The features will be varies, depends upon the what movement they are doing, whether it is bicep movement or tricep movement. So we can see the difference of the spikes of the signals, and we can capture the feature face. Based upon that, we can vary the which part of body they are doing that motion. Then from these feature spaces, when you go give it to the ML model, then using that ML or DL model, we can go for the recognition of the movement analysis. Okay, this is the general overview of the technique deployment in the artificial intelligence. So when you go for key challenges, still it is an important thing as per the challenges is concerned. The data variability, as I mentioned, the data variability in the SEMG signal, the proper placement of the electrodes, and gathering the physiological factors like an signal patterns. So that is making the model very complex. So this gathering of the information could be standardized one. So still in the surface EMG, it is not, and there is no standard gathering the information from the signals. I mean the EMG signals. So that has to be overcome, and after that, the real-time processing. So that is also one of the important factor. So the computational challenges will be facing by the different neural networks. So which we are discussed in the literatures. Most of the neural network which is listed there will have a very high computational complexity compared to the binary neural network. But the binary neural network is very lighter in weight anyway, but it will provide only the classification of two classes. But for the multi-class classifications, we require the advancements. So it may increases the computational cost. So that could has to be considered in the future. With a very low power, low computational cost, we have to go for the preparation of, I mean, we have to develop the system for the classification to applicable for the real-time processing. Then the clinical translations, the translation of your prototype to the clinical implementation. That is an important challenge what we are facing. We have to overcome the regulatory which is provided. I mean, there is some standard has to be there to transform your prototype into the clinical deployment. So that we have to be still facing and challenges in these phases. Then after that, the future direction is concerned. So the personalized recuperation. So the patient has to be there in their home, and they have to do their treatment plans, and they have to do their rehabilitation also in their home to monitor how the process of the each and every improvements they can able to visualize. So the personalized recuperation is one of the important concern in the future. Then the advanced algorithms. So the AI algorithms will have to improve its accuracy and also its efficiency. So as we said in the previous literatures and all, most of the neural networks computational cost is very heavy. So we have to concentrate on those things to make an advanced algorithms with the optimized way to provide multi-class processes. Then the human machine interfaces. So interaction between the users and the machine is an essential effective rehabilitation process for the machine interfaces. So will it encouraging the patients to do the better improvements in their process of rehabilitation. So in this future directions is concerned, when we go for the personalized recuperation, my recommendation to develop the web application like remote monitoring applications, with very lightweight deep learning models. And also the advanced algorithms is like we have in the current spaces, there is much of research is going on with the transfer conversion networks. So as per my knowledge, I'm just saying this information. The transformer convolution networks are very much uses in the nowadays research. So with preparation of lightweight transform conversion networks, which helps the classification process and making the accuracy and the efficient system design. And human machine interface is concerned, the VR VR based systems. So where the patients can able to engage themselves by means of playing the game, and they are going for the rehabilitations. So this makes the patients with the effective engagement as well as the getting the feedback in the real time. So these are all the some of the human machine interfaces which is available, and the easy implementations can also able to be done. So with this, I just conclude my presentation. So actually, this review highlights the recent advancement in the, especially in the concerns of AI-driven systems for the muscle motor control rehabilitation, which is usually utilizing the surface EMG, and also it is it is highlights the significant issues, and whether it is subjective specific differences on data sets and the clinical applicability. So those things and all we have discussed earlier. So those highlights will be what are the important significant issues are present in these systems all will be listed. Then after the future research, the energy efficient AI models and interpretable design of developing the models and generalization across the various uses and context. And as well as the last we have just discussed, I just presented about the gap which is there from the prototype conversion, prototype to the translation of the clinical implementation. Okay, then after we can implement these systems in the multimodal biosignals and federated learning with the embedded approach. So these are the some of the process we can able to do in the future to bridge the gap between the laboratory prototypes into the clinical translations. So with this, I am just conclude my presentation. So these are my references which we are taking. Then thank you. That's it from my side.
Okay.
Any questions?
Next topic is diagnosis of schizophrenia using statistical analysis of assessment tools. Nandi Manikam?
Yes, sir, I'm here, sir.
Okay. You may share your presentation and begin presenting.
Sir, is my presentation visible, sir?
No. No, it's not.
No. Thanks. Now, sir?
Just a second. Yeah, now we can see your presentation. You may begin.
Yes, sir. So, good evening to one and all present here. So, today's topic is diagnosis of schizophrenia using statistical analysis of assessment tools. And I'm Nandini, research scholar from SRM Institute of Science and Technology. And I'm working along with my co-author, Dr. P. Vijay Kumar, Professor, SRM Institute of Science and Technology. So, one second. So this is my presentation flow. I'll go out with my background study, introduction, objective, methodology, data collection and analysis, statistical analysis, conclusion, and references. So to begin with, according to the World Health Organization, nearly 1 in 7 people in the world are affected by mental disorders. And mental disorders are basically characterized by significant disturbance in emotional regulation, cognition, and behavior. There are different types of mental disorders. The main common disorders that we have come across is anxiety and depressive disorders. But schizophrenia is one among the disorders which is not so common since it is persistent and it can be severe if it is not treated properly. So coming into schizophrenia, schizophrenia is a severe mental disorder that is characterized by disturbances in the way of things are perceived, emotional responsiveness. They lack in responsiveness and they lack in social interaction. Nearly 24 million people, that is around 0.33% of people, are affected by schizophrenia worldwide. So the main cause of this schizophrenia is psychosis, where a person feels difficulty in distinguishing between what is real and what is not. And the schizophrenia is frequently associated with stress and impairment in personal, family, social, educational, and other fields of life. And there are more likely, like 2 to 3 times, people are to die compared to that of the general population. And the main cause of this is that they prefer social exclusion. They don't involve much in social interaction. They have lack in motivation and they show less impacts on relationships. So, for a better diagnosis of schizophrenia and in order to distinguish the severity of the symptoms is very important in an effective diagnosis. So, here are the symptoms that I have mentioned. So there are three types of symptoms. One is psychotic or positive symptom, negative symptom, and cognitive symptom. So under positive symptoms, it is characterized by hallucination, where people are able to have like they are able to see things which are not visible to others, or they are able to hear which are not able to be heard by others. And delusion, where they have a false belief on which is not real. They Then again, the next characteristic is disorganized speech or thoughts, and they have abnormal movements. And coming into negative symptoms, they show lack in social interaction, they show lack in speech, they show lack in getting like pleasure, they don't show much happiness. So these are the negative symptoms, and cognitive symptoms are related with low attention, poor decision making, and lack of problem solving. And we are mainly concentrating on the positive symptoms. So the main objective of our work was to assess the severity of symptoms of schizophrenia through statistical methods. And we had used three assessment tools, that is positive and negative syndrome scale, which is for assessing the positive and negative symptoms. Scale for assessment of positive symptom, which is for assessing the positive symptom, and negative symptom scale, that is for assessing the negative symptoms. And after all these assessment tools were given to the patients, and it was being assessed. And based on the scores, the validity and reliability of data for both healthy controls and schizophrenia patients were determined. And through statistical techniques like ANOVA, t-test, and chi-square test. So participants were taken based on the inclusion and exclusion criteria. So first we are going in for data collection. In the data collection, as I told you before, we are dealing with positive and negative symptoms. So three assessment tools are being used: PANSS, BNSS, and SAPS. So we went through the collection of data through online for control patient LD controls, and offline we went through SRM Hospital Research Center for getting the patient's data in offline mode. And then these data were analyzed through statistical techniques like ANOVA, t-test, chi-square, and reliability tests like coherency and Grammer's view. And the reliability and validity test was taken, and then we had diagnosis what the presence of severity of symptom. So each assessment tool, that is PANAS, had 20 questions, positive symptoms SAPS has 20 questions, and negative symptoms BNSS had 20 questions. So we had divided this like into control group and schizophrenia patients. The control group was being given through Google Forms to the public, and we got responses around 45 responses, and the age criteria, the group from 25 to 50 years. And the 45 responses were from 13 male and 32 female. And the schizophrenia patients were collected from SRM Hospital College and Research Center, where we received 57 responses, which comprised of 22 male and 35 female. And the age criteria was between 17 to 73 years. So the threshold we had set for each scale was, if in case the score is below 60, they come under control group. And if in case the score is above 60, the schizophrenia patient, they come under schizophrenia patients group. So like that only we had, for each and every scale we had assessed. So first for PANAS, we had divided into control group and everything. Out of the 45 responses, 35 responses was below 60, which comprised of 11 male and 25 female, and 14 were above the threshold, which we excluded in the study. And similarly, for schizophrenia patients, out of 57, 23 are above 60, which comprises of 10 male and 13 female. So with this, we took into the study. The others were, the remaining were below 60, which we were maybe because they were coming for regular checkups, they were under like say like they were under regular follow-ups and medications. That's the reason they were having a lesser threshold. The similarly for SAPS also, out of the 45 responses, 38 responses were below threshold, so that which comprises of 12 male and 26 female. The remaining 7 was excluded from the study. And similarly, in schizophrenia patient, out of 57, 18 was greater than 60, so we took that in for study, and the remaining 39 was under regular checkups and follow-ups, so that we excluded from the study. Similarly, for BNSS also, out of 45 responses, 32 responses showed below 60, which comprises of 12 male and 20 female. And remaining 7 was greater than 60, so we excluded from the study. And similarly, in schizophrenia patient, out of 57, 19 was greater than the threshold, that is, which comprises of 9 male and 10 female. The remaining 836 was coming for regular follow-ups and medication, so that was excluded from the study. Then we took these data, we used like Likert scale, and we coded the thing scores. And out of that, the data was collected in the form of CSV file, which was extracted using Python to analyze the reliability and validity. So the validity of the data was analyzed through ANOVA, t-test, and chi-square test, whether the data is statistically significant or not. And to analyze the reliability of the test, inter-rater reliability test was done for measuring the magnitude of the difference between the two groups, control data and the schizophrenia patients. So this was the statistical report that we had got through. And so from this, we were able to analyze that the results had shown, we had taken a small sample. So in that small sample, it supported reliability and validity, and it showed really like across different demographic difference across groups, it showed a good result. And PANAS scale showed the higher F statics for schizophrenia patients, and was statistically insignificant. And these assessment tools were effective when they are taken for a small group of data. So the problem was, if we are taking for a large set of data, we had to check with we had to evaluate and estimate with the statistical technique. And also in future, we are planning to take up large data set, and also to integrate this with physiological data and audio and visual data, so that we can track the severity and look into for the effectiveness of the treatments of the patient. So this can help in enhancing the effective diagnosis of schizophrenia. So these are my references. Thank you. Yes, sir.
Thank you for your presentation.
Yes, sir.
Do we have any questions from the audience? I guess not. So thank you again, and we can continue to the next presenter. The next topic is food freshness detection using AI. Presenter is Nikhil Wiamar.
Hi sir, can you hear me?
Good afternoon to all. Today I am delighted to present my works vehicle lightning maintenance system for the vehicle light monitoring, expiry and the urgency levels. Introduction. In vehicle lightning plays a crucial role in the visibility, communications and the overall road safety. Modern vehicles now use the advanced technologies like LED, HID, it's like a high intensive discharge and the laser based lights, which are more efficient but also more complex. Even though the lighting systems have the evolved significantly, that maintenance the approach has not. Most of the vehicles still depends on the manual inspection, which cannot be identified earlier this or the electrical degradation. Because of many lightning fails happen gradually or the notified to the driver. Unexpected breakdowns becomes the common, especially during the night driving or harsh weather. This highlights need tool for the continuous automated and data driven monitoring systems that can track the health of lightning and components in the real time. By doing so, we can detect the problems earlier and improve the reliability, enhance the road safety, and avoid the sudden failure problem state. In this most negligible components in the maintenance cycles. In many cases, lighting systems degrade slowly, but the drivers or owners only notice the problems when the light completely fails, often during the night time, posing a safety risk. In real world issues, including
Okay, we can see your screen now. Yeah, now we see presentation. You may continue.
No, sir.
Sorry for the interruption.
In this main objectives of this project, it's built to the complete the lightning's life cycle management system. This includes the automated data collection by using a sensors to continuously measure the brightness, voltage, current, and temperature. We are eliminate the manual inspection. Second one, it's the intelligence monitoring. The microcontrollers process the sensors values and detects any abnormal deviations. Predictive maintenance. The machine learning models analyze the degradation patterns and they estimate the remaining useful lives of the each light unit. Allows to users and the companies. Real-time notifications for ensure the lightning falls and not miss. Maintenance history of the tracking. The system logs or installs dates, expiry predictions, and the replacement actions to the form of the complete records. System overview. In the system design by using a sensor to monitor each vehicle's lights and the sensor collected the data to microcontroller. The machine learning algorithms are analyzed to conditions of the lights. It will be predict the when lighting is to the vehicle owner or once the light is replaced, the system updates the data to the current What's the workflow? In this sensor data collection, the sensor installed near lightning models measure the key parameters. For the example, a decrease in a lumens combined with the microcontroller processing at the ESP32 or the identify the earliest terms of such as the transmission. The process data is transmitted to the Wi-Fi or Arduino BLE sensor and the CAN bus. It is ensure that this predictive analyze the trends. The brightness shows the downwards a slope of temperature, or the temperature it increases day by day, and the model predicts when the light is will be fade. Urgency classification. Lights are classified into the normal, moderates, criticals, and the expired. For example, a brake lights with the 2 days of predicted life will be marked as critical. Alert dashboard. Users and the service companies receive the notification, and the dashboards display the overall health and upcoming replacements, maintenance and updates. When the light is replaced, the system locks on the new installation data and the resets. Core layer. Here I will explain the core layer, the makeup of our vehicle lightning maintenance systems. Each layer plays a specific role. The first one is sensing layer. Where the sensing layer continuously monitoring the key parameters such as brightness, voltage, current, and temperature. And the processing layer. Handle the microcontroller. This is noise was filtered out and the important of features are extracted. This microcontrollers also perform the initial fault detection. Communication layer is the responsible for sending the process to the backend system, depending on the analytic layers, where the machine learning or the deep learning models analyzing incoming the data. These models detect the life of each lightning components. And the classification layers. Categories of each layer have no user the understand the lights need the immediate attention. Visualizing and alert layer. This display lightning's health or dashboards and the sends the alert to the vehicle owner and the service company when it's an issue or near expiry events is detected. Finally, the maintenance and the updated layers. Ensure the long term of accuracy. Once the light is replaced, the system records the new installation date and restart the monitoring, completing the entire maintenance cycle. Collecting the real-time brightness, temperature, like filter sensors data instantly. Since the process data to the server for very remaining lives under the alert and the
We have a bad connection with Tenu. Basically, we're gonna finish this conference on this. Thank you all for participating and thank you all for listening to us. Today's session is over. We see you next year, hopefully. Thank you all for participating.